Question 15, we've got two curves. One is a cubic, one is a quadratic, and we've been asked to verify that at x equals 1, the curves intersect. If they intersect, they have the same y value. So if we put x is equal to 1 into both of these equations, do we get the same y value? If we do, they intersect. So we're substituting x is equal to 1 into both of our equations here. For C1, we get that y is equal to 8 minus 10 plus 6 minus 1. And that turns out to be 3. For C2, we get y is equal to 1 minus 12 plus 14. And that also turns out to be 3. So the conclusion is they meet at the x value, which is 1, 3. Now part B. The curves also intersect when x is equal to k. Given that k is less than 0, use algebra to find the exact value of k. Well, again, if they meet, they must have the same y value. So what we've got to do is set the cubic equal to the quadratic, muck it around to a single cubic, and factorize it. That will find the x values where the curves meet. So this is C1 and this is C2. And we've just got to move these all around to form a single cubic. And if you do that, you'll get that x cubed minus 5x squared minus 2x plus 6 will equal 0. And we know that x minus 1 is a factor of this cubic because we know the lines meet at x is equal to 1. Now, I personally hate doing algebraic long division. I'd much rather take this out as a factor and assume that the remainder is a quadratic. This is what I mean. Here's our cubic. X minus 1 must be a factor, and what remains must be a quadratic. And here's the general form of a quadratic. The values of a and c will pop out straight away because the multiplication of those two terms will generate the x cubed term. And the multiplications of those two terms will generate the 6. So that therefore, straight away I can say that a must equal 1 and c must equal negative 6. So how do we get b? Well, we can get b by working out all the multiplications here that generate this x squared terms. Which of the multiplications generate x squared? Let's just go through it. Well, there's one there. And here's another one. And that's all. So using the red lines, I can say that 5x squared, negative 5x squared, must be equal to these two multiplications, which is this one here, which is negative ax squared, and this one here, which is plus bx squared. We can lose the x squared, so we get negative 5 is equal to negative a plus b. And we know that a is equal to 1, so b is equal to negative 4. So I can substitute back into our equation here, and I get that x minus 1 must be multiplied by the quadratic x squared minus 4x minus 6. And if you factorize the quadratic, you will get that x is equal to 2 plus the root of 10, and x is equal to 2 minus the root of 10. And these are the possible answers for k. But we're told that k is less than 0, so only this answer will satisfy their requirements. So therefore, as k is less than 0, therefore k is equal to 2 minus the square root of 10. And that's the answer.